Hey guys, we're looking at your Unit 3 study guide. So if you're here, you're using this video while you're completing the study guide, or it is now during the exam and you're here for a sample to reference what was going on. All right, so again, for our study guide, it is organized based on the questions that you will see on your exam. So for question number 1, it is something about maybe a sample space, something about probability. So again, use this video for reference for each whatever question you're working on. Okay, so for this first one, question 1, let's dive right in and see what's happening. So a standard 6-sided cube is rolled. We're going to start by drawing out the sample space. So remember, sample space is all of our possible outcomes. I'm going to even write that in here. Sample space is our total number of outcomes. Total number of outcomes. So if we have a cube, a 6-sided cube, I don't know why they're not naming it as a dice. It's a dice. That was probably my bad for not showing that. Okay, there you go. Beautiful. So what could you roll? You could roll a 1. You could roll a 2. You could roll a 3. You could roll a 4. You could roll a 5. Who would let me draw a 5? Or you could roll a 6. So if you have a dice, you roll it. There are 1, 2, 3, 4, 5. There are 6 outcomes, 6 possible answers here. Back that up. 6 outcomes. So now we want to find the probability of getting a number greater than 1. So we need to think about this, do a little side work here on a number line, a number that is greater than 1. So thinking back to inequalities, if something is greater, right, it's a number larger than 1, but it's not saying greater than or equal to. So it seems like it is non-inclusive. We are not including 1 as an option. So we're choosing numbers that are not 1, that are larger than 1, but our limit here is up to 6. But we can include 6 as an answer because that's also larger than 1. So it's numbers between 1 and 6, but not including 1. So let's go ahead and look at that. So number 1, we can't include it, but number 2, yep, that's greater than 1. 3, 4, 5, or 6, all of those work. Those are all numbers that are greater than 1. So when we're finding the probability, remember our formula. And again, if this is your exam, this is the kind of work we need to see, showing all of our steps, rewriting the formula, all this good stuff. This is what we're looking for. So rewriting our formula, it was the number of favorable outcomes. I don't know why that is so gigantic text. I'll leave it. It's fine. It's really important anyway. Okay. Number of favorable outcomes divided by the total number of outcomes. Remember, that is how we calculate probability of an event occurring. So let's see, we've got 1, 2, 3, 4, 5 outcomes that are greater than 1 divided by our total, which is 6. Again, for our class, we're writing our probability as a percentage. So that is the same as 0.833%. We move a decimal place over 2 place values. So rounding to the 10th place, this is just 83.3%. That is a very large chance, right? Remember, our probability of an event occurring, that percentage or that number, decimal fraction, is between 0% and 100%. So an 83%, that is right, certain, almost certain to happen. 100% chance probability, it's going to happen, it's certain. 0%, it's impossible, it can never happen, right? If you're rolling a 6-sided dice and you're trying to, on one roll the number 10, that's impossible because there is not a number 10 on a 6-sided dice, unless you have a fancy dice that does that. All right, so 83.3% chance for this one. All right, remember, for every question, there is a bonus question. This is meant for you to try this on your own. Draw it out, the sample space, draw the picture of a coin flipped calculate probability of getting tails, and then once you're ready, you can scroll to the bottom to check your answer. So again, the bonus questions are meant for you to try on your own, so I'm not going to go through them in this video. All right, question number 2 is going to be another sample space problem. It might look something similar to this. Let's go through it. So a spinner has 8 equal sections labeled, and we can see they're all labeled, numbered for us, and colored, and they're colored. It's really pretty. List out the sample space. So what is the sample space? We could roll a number between 1 and 8. So I'm going to show that sample space. We could roll a 1 or spin a 1. I don't know. I guess spin a 1, 2, 3, 4, 5, 6, 7, or 8. There are 8 total outcomes. 8 total outcomes. What's the probability of getting an odd number less than 5? So again, probability, because I'm a little lazy and I already wrote this out, I'm just going to copy and paste, which you are welcome to do also on your end. You don't have to rewrite it every time. If you have it on another slide, it's the beauty of Desmos. We can go back. All right. So number of favorable outcomes divided by total. What are we even finding the probability? Wait, what's going on? What are we trying to do here? I skipped some steps. What's happening? Probability of getting an odd number that is less than 5. So notice it says less than 5, not less than or equal to. So we are not including 5 as an option. So this is why we list out the sample space. I know you're like, Mrs. A, why do I have to do this? Why do I have to show all these numbers when they're already right here? I know. This is just the process. We have to list out the sample space. It was asking us to do that, so we gotta do that. So the sample space, now we want to find a number less than 5. Less than, not including, not less than or equal to. So an odd number, 1, 3, 5, and 7 are all the odd numbers here. But a number that is odd number less than 5 is just going to be 3 and 1. They are odd and they are less than 5. Less than 5. So favorable outcomes, there are only 2 numbers that are less than 5. And our total options were 8. So that's the same thing as 1/4, which is the same thing as 0.25 or 25%. There is a 25% chance that if you do this spinner, you're going to land on either the number 1 or 3, because those are the only odd numbers that are less than 5. All right, because remember, odd number, it's not divisible by 2, right? Everything else even, divisible by 2. So odd, less than 5, not including 5, not less than or equal to, just less than, below 5. Okay. All right. This is a recording, so I don't know how you're feeling on this, if you're feeling good or not. But you can always ask me questions. Not right now, but like you can message me if you have a question. All right, so I've got a bonus question with some candies. Same process, and then try this on your own and scroll to the bottom to check your answer. Your question number 3 on your exam is going to be a note check. So make sure, hope you've been following along with your Engagely notes. If not, then that might be a problem. You might have to go back to the playback room for this one to answer that question. All right, now question number 4 is going to be about overlapping and disjoint. So let's see what's happening here. Can I scroll down a little bit? Here we go. Okay, perfect. Overlapping and disjoint. A card is chosen from a standard deck of 52 cards. Are the events of drawing a black card and drawing a heart overlapping or disjoint? We need to circle one. So a black card. So let's refresh back to our suits, right? From our Engagely notes too, we added a picture of the deck of cards. Wink, wink. We added that picture. Might have needed that on question number 3, maybe. Anywho, there are 4 suits, remember, in a deck of cards. There is the clubs, which I'm gonna try my best to draw. That's actually not too bad for me. There's clubs. There's a spade. Spade. For red cards, there's a heart. And there's a diamond. Diamond card. Okay. In each of these, remember there are 13 cards in each suit. There are 3 face cards. The rest are numbered, except A means number 1, ace. Okay, so what are we doing here? Probability of drawing a black card and drawing a heart. So black card, there's clubs and spades. Hearts, remember when we're trying to determine is this overlapping or disjoint, we need to think, can we have a card that is both? Can we have a card that is both black and also a heart? If we can, then there's overlap. If we cannot, then it's disjoint. So it looks like a heart is a red card. We can't have a black heart. So this is going to be a disjoint event. We're going to circle that. And we're going to draw this Venn diagram to show this. So I'm going to show the black cards. Black cards. And there are, out of 13, so 13 times 2, that would be there are 26 black cards. And then for a heart, there are 13 hearts. So this is our Venn diagram showing what's happening here. We've got our black cards, and then we've got the heart. So now we need to find the probability of drawing a black card or a heart card. So we're going to need to reference our notes, and give me a moment, I'll get those pulled up. So for you, you can check on your Engagely notes to find this formula for probability of, this is the compound events for disjoint. So because it is a disjoint event, I'm just updating from our Engagely notes. So probability of A or B is equal to the probability of A plus the probability of B. That's how we're going to find the probability of either or for a disjoint event. So the probability of drawing a black card, there are 26 black cards out of a 52 deck. That's event A. Probability of event B, there are 13 hearts out of a 52 deck. So that is going to be 39 out of 52, which I think is 3/4, but right, because there's 3 suits out of 4, but we'll just confirm just for the sake of this video. Yep, 1/4, so 75. Let me close that out. So this is 0.75. So this is a 75% chance for probability that if you are drawing a card from a standard deck of cards, 75% chance that you're going to draw either a black card or a heart, right? Because that is 3 suits out of the 4. So it's very likely to happen, right? Maybe less likely, 25% chance that you're going to draw one individual suit, like a diamond or a spade. But to draw 3, if you really don't want diamonds, right, if you're trying to avoid this certain suit, you have a 75% chance that you will avoid that one suit. Okay. Overlapping disjoint. So bonus, try this one on your own. Different event, same process, and then you can scroll to the bottom to check your work. All right, our last problem, question number 5, is looking at two-way tables. So we're going to fill this in and answer some questions about this table. So let's see. Students were surveyed about their favorite after-school activity. Complete the table. Okay, so let's start there. So I'm seeing for our marginal frequency, our total being 12. So 12 minus 3, so 12, 11, 10, 9. This one here is going to be 9. 9 plus what is 14? Should be 9 plus 5 is 14. 25 minus 12, that's going to be 13. All right. 13 minus 5, so 13, 12, 11, 10, 9, 8. 8, 9, 10, 11. And yep, 14 plus 11 is 25. Okay, so it's all filled in. We're just kind of using those marginal and joint frequencies to check rows and columns to piece together. Again, I like to think of it as like Sudoku. I'm not going to pretend like I know how to spell that. Sudoku. I think that's right. I'm going to go with it. I think that looks right to me. Okay. Anywho. Part B, find the probability that a randomly selected student is an 11th grader who prefers sports. So we are talking about a joint frequency. 11th grader who prefers sports. 11th grader who prefers sports. There are 9 students in 11th grade that prefer sports. Out of 25, let's see what that is. 9 divided by 25 is 36%. So equals 36%. There's a 36% chance that you are in 11th grade who prefers sports. And a student says, most 11th graders prefer sports. Use the table to determine if this is true. Explain using the table. So this is where we're gonna have to type out our answer in part C, because we're reading the table, reading the statement, determining if it's true or false, and explaining. So this student says most 11th graders prefer sports. Okay, so let's compare most 11th graders. So here are 11th graders on this row here. There are 12 11th graders that were surveyed, and 9 of them preferred sports. And that is more than those that preferred video games. So most 11th graders prefer sports? Yeah, it looks like they do. More 11th graders prefer sports. Or even if we were looking at it in our row, I guess it depends which way you're looking at it. But in our row, even then, compared to 12th graders, more 11th graders preferred sports. So that's kind of cool that it fit both. I don't know if that's going to be always the case, but just looking at 11th graders, so using the table, so there are 12, we'll say 12 11th graders were surveyed, 9 preferred sports, and only 3 video games. So I agree, most 11th graders prefer sports. Preferred. I think I'm missing an R. Yeah. All right. So 12 11th graders were surveyed, 9 preferred sports, and only 3 video games. So I agree that they preferred sports. So you're just kind of reading the table. Do you agree with that statement or not? They might be true or false. All right. Bonus. High school, middle schoolers. Pizza versus burgers. All right. And then for this one, you're, instead of answering if that statement is true or false, you're answering, is the event middle school and prefers pizza, overlapping, or disjoint, and you're going to explain. All right. And then that's it for our study guide. Any questions at all, please let me know. Cam's inbox. That's it. I hope this helped give you a start, an idea of what your exam is going to look like, or just some help with, if you're in the exam, what to do, what it looks like in showing your work, showing all those steps. All right. Take care. Bye, guys.